Okay, hey guys, today we're talking about dividing integers. This is chapter 2, lesson 5. So the expression below, negative 45 divided by 5, is an example of dividing integers. Division of integers is related to multiplication of integers in many different ways. So one way to find the quotient, or the answer of a division problem, is by using related multiplication sentences. So here I have the multiplication sentence, 5 times negative 9 equals negative 45. Well, to find the quotient, you can think of that factor as the quotient. So that leads us to our division problem, which is negative 45 divided by 5 equals negative 9. So in the division sentence, notice that the dividend and the divisor, meaning this number and this number, have different signs. So the quotient is negative. This suggests a rule for dividing integers with different signs. So here, remember that the quotient of two integers with different signs is always going to be negative. So a negative 10 divided by a positive 5 gives us a negative quotient. A positive 10 divided by a negative gives us a negative. All right, let's take a look at A. Here I've got a negative number divided by a positive number, and I know a negative divided by a positive is going to give me a negative number. 35 divided by 7 gives us 5, and so negative 5 is my answer choice. B, I have a positive divided by a negative. A positive divided by a negative gives us a negative. And 64 divided by 8 gives us 8. So your answer choice would be negative 8. You can also use multiplication and division sentences to find the quotient of integers with the same sign. So in the equation here, negative 3 times negative 12 equals 36. You can think of that factor to find that quotient. So by switching around that equation, I'm going to get 36 divided by negative 3 gives us negative 12. So this is also going to suggest a rule for same signs, okay? So the quotient, or the answer of a division problem of two integers with the same sign now is going to give us a positive answer. So a negative divided by a negative is going to give us a positive. Again, a positive divided by a positive is obviously going to give us a positive. Taking a look at the next example on A, it says just find the quotient. So we have a positive being divided by a positive, which we know is going to give us a positive answer. And 48 divided by 12 gives us 4. Now some of you are going to say, hey, do I have to write the plus sign there? No, you don't. You just write regular positive integers without a plus sign in front of that. Again, a negative over here on B divided by a negative is going to give us a positive. Now, some of you are going to look at that and you may get confused. Last year I told my kids that if you, hold on one sec, if you can, try to think of it as a negative divided by a negative can always make a positive symbol. Okay, so a negative divided by a negative is going to give us a positive, and 56 divided by 8 gives us 7. So a positive 7 is my answer choice. Next, we're going to evaluate each expression by just substituting in the values for those variables. So I have 12 times y, which is negative 3, divided by x, which is negative 6. Once again, guys, notice that I am isolating any of my negative integers in parentheses. You need to make sure that you're getting in the habit of doing that. And then following the order of operations, I know I need to take 12 times negative 3 first. A positive times a negative is going to give me a negative, and 12 times 3 is 36. Continue to write out the rest of your problem. And now I can see that I have a negative divided by a negative, which is going to give me a positive something, and 36 divided by 6 gives me 6. So a positive 6 would be my answer choice. And this just kind of breaks it down for you. All right, looking on to B, I have negative 5 times x, which is negative 6, divided by negative 3, which is y, what we were substituting in for y here. They show you it did the exact same thing here. I need to follow the order of operations on top, so I know that a negative times a negative is going to give us a positive, and 5 times 6 gives us 30, and I have to divide that by a negative 3. When I'm dividing, I know that I have a positive divided by a negative is going to give us a negative, and 30 divided by 3 gives us 10. Negative 10 is my answer. All right. So now we're going to talk a little bit about the mean, which is also called the average. Division is used in statistics to find the average or mean of a set of data. To find the mean of a set of numbers, find the sum of the numbers and then divide by the number of items in that set. So if I take a look at the first example here, it says the wind chill temperatures in degrees Fahrenheit for 7 total days were -6, -5, 2, -10, 1, -9, and 6. Find those mean temperatures. So again, the first thing that we do is we find the sum of the numbers. Okay, sum meaning that we are adding. So let's do that. And then we divide by the total numbers in that set. Well, let's figure out how many numbers are in that set. They told us that we had 7 total days, and let's match that up. We've got 1, 2, 3, 4, 5, 6, and 7 different temperatures. Okay, so they just show you right here that you're adding all of those integers together, and then you divide by the total number of items in that set, which is 7. So if I look here and I take -6 plus -5, that gives me -11. -11 plus 2 more gives me -9. -9 minus 10 more gives me -19. -19 plus 1 gives me -18. -18 plus -9 more gives me -27 more. And -27 plus 6 gives me a -21. So I'm going to take -21 and divide that by +7. Here again, I'm taking a negative and I'm dividing it by a positive. And we know a negative divided by a positive is going to give us a negative answer. 21 divided by 7 gives us 3. So -3 is my answer, but it's asking me for what? Find the mean temperature. So I would say -3 degrees, and my unit was in Fahrenheit. Okay, this last slide here kind of breaks down what we've talked about in the first few sections of Chapter 2. We talked about adding integers. If you have integers, when you're adding them with the same sign, you add their absolute values, and the sum has to be that same sign. Remember, I talked about the same sign sticks with your answer when you are adding integers. When you have different signs and you're adding integers, you subtract those absolute values, and the sum that has the same sign as the integer with the greater absolute value is the sign that's going to that you're going to see in your answer. When you're subtracting integers, to subtract an integer, you add its additive inverse. Remember, like additive inverse of 4 would be a -4. And when you're multiplying and dividing two integers, you know that same sign products and quotients are going to be positive, and different signs of those products and quotients is going to be negative.